Right. Sorry, guys, we're slightly late with the beginning. I hope you'll give us a couple more minutes. We're still waiting for some of the guests to arrive. Some of the lucky ones amongst you managed to get through the queue at the entrance pretty quickly. We're still waiting for some of the other ones. So I hope you won't mind. We'll start, I think, in about 5 minutes with the official welcome and then the first panel. So if you have 5 minutes now, there is time to go on social media or download our app for this conference. Just go to the website for the Women in Tech Summit and find the event app. I very much recommend it because there were some last-minute changes to the program, so please either go on the website or download the app so you're always up to date. I'd also like to encourage you to go to Twitter or Facebook and use #Perspektywy. The sign you can see over there tells you what hashtag to use. So you have some spare time, why not try and connect with everybody else there. I'll be back with you in 5 minutes, I hope, introducing everybody to each other and you to our distinguished guests. Thank you so much for your patience.
Two for the blues, baby and me. Two for the blues, blue as can be. Two for the blues, couldn't agree. Two for the blues, indigo hue. Two for the blues, what can we do? Two for the blues, said we were through. Other night, had a fight, quite a spat, and that was that. Now we're each so lonely, missing our one and only, wondering how to lose our blues, blue our fuse. Got these blues, we're too blue ones, too troubled but true ones, both hating to break up, both ready to make up, both weeping and wailing. So what are we doing? Blueing all day. I'm waiting for his call. He's waiting for my call. I call and he calls me. The lines are both busy. So what are we doing? Blueing. Two for the blues, baby and me. Two for the blues, blue as can be. Two for the blues, couldn't agree. Well, I just can't believe our love is through. Gotta end these blues for two. Blue, blue, blue.
Ladies and gentlemen, let me welcome you to this 2018 Women in Tech Summit. Thank you so much for turning up in such a large number today in the morning. I was frankly expecting everybody to be slightly late, but I know you were stopped mostly by the queue at the entrance. As far as I know, we will have this entire hall packed within just next 5 to 10 minutes. Some of you will have to actually keep standing because we're overbooked for today, which is obviously a good thing. We want to have as many of you attending the sessions, the workshops, the panels, the meetings, and the gala in the evening as possible. So on behalf of the organizers, I wanted to welcome you. But also, I was asked to introduce myself, but I figured what I should start with is introducing the most important guests here today. And it's you, the audience. So before we actually start, give a round of applause for all of you. Because I believe that introductions is what this kind of events are all about. And I would love to introduce myself to every single one of you, but you know, that's going to be a bit difficult from stage. So what I will start with is I'll ask you to have a look to your left, have a look to your right, look at faces around you, and try to spot people you haven't met before. And to start with, I'll give you half a minute to a minute. Please try and introduce yourself to at least one new person you haven't met before, right now. Thank you so much. I hate to interrupt you now, because it started so well. But fortunately, you will have the entire day today, the gala in the evening, and the day tomorrow to continue the conversations you have just started. And if you struggled with finding somebody new, well, that means you were most likely surrounded by your friends mostly. Let there be the lesson for you for the rest of the day. Try and meet new people everywhere, both here, outside in the main hall, during the workshops and during the seminars. Now, I was thinking how should I introduce myself? Because as you might notice, I'm not a very well-fitting host for this conference. There's one word here that doesn't quite work with me. And I have to admit, there are two reasons why I'm here. First of all, I'm standing in for a woman host who was supposed to be here. Zuzanna Lewandowska, who will be your host tomorrow. She couldn't make it today. But secondly, you know, like most of us, I have a personal reason. Now, I'm a dad. So if I have to introduce to you myself as someone, I would love to introduce myself to you as a dad. But I'm a dad of a boy. My son was born about 1.5 years ago. And since then, I've been spending my free time making toys for him. I mostly make cars and rockets and airplanes. And recently, a friend of mine came to me and said, "You know what, Kuba? You're so lucky. Because you get to make all these amazing toys, the rockets, the spaceships, etc., for your son. I don't have a son, I have a daughter." And I looked at him thinking, what's the problem? And you know what? I feel absolutely blessed. Because in February next year, my first and my wife's first daughter will be born. And you know what? I hope to keep making spaceships and rockets and airplanes and every other cool tech gadget that I can think of for both my son and my daughter. But I don't want only me to be the person that does it. I want the whole world to treat them like that. And for the world to treat them like that, I need the world to change a little bit. And that's why I'm so happy to be hosting today, because I believe that you, in here, are the ones that will make that change come. So, but introducing myself for real, I'm also an astronomer. I work at the Copernicus Science Center, where I work for the Education Lab, and I'm a founder of 2 NGOs that help scientists communicate. I'd love to introduce myself to you one-to-one, so if you have some time during the rest of the event, please come and introduce yourself to me. Oh. So there's an announcement. If you drove a Volvo here, there is a chance you're obstructing the passage some way. So make sure to make your way to the parking. So Before we go any further, I'd like to make a couple of housekeeping announcements so we are all on the same page. First of all, if you haven't gone to our website recently, or if you haven't downloaded the conference app, please do so, because the program is changing quite rapidly, actually. So please use the app and use the website to make sure you stay up to date with all the events, all the workshops, all the seminars. Now, second information, you have noticed that just behind you, behind this wall, there's the main entrance hall. There is a career fair going on there, so if you have your CV, if you want to talk with potential employers, please go around the stalls and make sure to talk to them. We would also like you to help us evaluating all the stalls. So if you go to the app, there is an option of evaluating everybody in the main hall. Please make sure to make use of it. I think there is a t-shirt you can win for doing that as well. If you were lost and if you were searching for your workshop or your seminar, please, you can always go to the registration or pick up there a program with a map of the entire expo area where you can see where your workshops are taking place. Now, if you're searching for the panel discussion or the main keynote speeches, they will be all happening here on the main stage. Now, the organizers also asked me to tell you, if you are on social media, you can use hashtag Perspektywy2018. That's the Polish word on the top, means perspectives in Polish. So you can use it on Twitter or Facebook or wherever you are. And also, if you need some advice on how to make it in the tech world, in the main area, there is a mentoring zone that you can always go to. Many of our speakers and many of our distinguished guests will be there. You will have a chance to go and talk to them. Throughout the day, I'll be also announcing who's going to be there at what time. And finally, there are some free spots left at every workshop. So if you haven't signed up for any of the workshops, give it a try. Try showing up in your favorite workshop. Maybe there will be a free spot there for you. And finally, if you haven't planned for it yet, today in the evening, we have Copernicus Science Center to ourselves. So please make sure to leave some time for 8 to 11 p.m. party today in the evening. So that's all when it comes to the housekeeping notes and welcoming you here. And because you made it so early today in the morning, you're the lucky ones. You'll actually have to get to take part in 2 openings. There's going to be a second grand opening at 12 p.m. today here. But please make sure to come in 5 minutes early, because we'll have a surprise for you. Now, I'm not going to go any further. I kept you long enough. It will be my pleasure now to introduce you to the co-founder of the Polish chapter of Girls in Tech, the person who brought Girls in Tech to Poland, Mrs. Renata Kaczoruk. Please join me on stage.
Thank you. Yeah, you can hear me now. It wasn't only me. It would be hard for only me to do it. It was mostly thanks to Kamila Hankiewicz. So that was Kuba Bochiński, the head of education in the Copernicus Science Center. Big brava for him. Thank you. I know you were waiting for a woman to welcome you to the Women in Tech Summit. Here I am. But we needed some diversity, you know. I am very delighted to be here with you in this room and see you all, so many of you. Although I must say I understand boys now more. It feels, it's incredible and hard to imagine how stressed you can get talking to girls, especially when there's so many girls in front of you. So talking about diversity, there will be at least 1 man in each panel today and tomorrow. There will be 3 panels today and 2 tomorrow. I'll be introducing you very briefly to all of them. And so let's start with the first one. So me personally, when I think about women in tech, first thing that comes to my mind is intelligence. So the first panel will be on artificial intelligence, because it's becoming very present in our artificial intelligence, because it's becoming very, very present in our everyday lives, even if we don't always realize it. But we sometimes perceive it as a threat, as something that can turn against us. We're constantly warned of AI stealing our jobs, the algorithms being biased, racist, sexist. And we do not feel ready to be controlled by some black box intelligent softwares. So how do we make sure that the artificial technology's actions are easily understood by humans? How do we make sure that they're being used responsibly, that they're being used transparently, and that they're built human-centric? This panel will be held by Alexandra Bracken. It's your turn now. Maybe. She's a research fellow at the Center for Collective Intelligence in MIT, and also she's an assistant professor at Kosmiński University. So give her a warm welcome. She's an extremely inspiring person whose expertise is so wide. It's ranging from philosophy for AI robotics to media and farther right. All right, I'll leave you on the stage. Good luck.
Thank you so much, Renata. Can you hear me well? Hello, everyone, and good morning. I'm very happy to be here to discuss with you probably the very core of the current tech, which is artificial intelligence, its current state and its further state. We called this panel Forget the Singularity, but we'll probably really not forget the singularity throughout the panel, and it will be a recurring topic anyway. So I have fantastic guests today who will be your speakers at this panel, as I'm your moderator. And I want to invite them to the stage now with obviously a warm round of applause on your side. So first of all, I would like to welcome Jody Medic from Singularity University, who is Director of Tech Design at Singularity University. Second of all, I would like to welcome our gentleman, Przemysław Chojecki, CEO of Ulam AI. And third, last but not least, absolutely, Ulrika Jägere from Ericsson, who is Director of Technology and Architecture, reporting to the CTO of Ericsson. So please join us at the stage. Let's have a seat. So quite obviously, artificial intelligence is a topic that is very much a buzzword. This has positive sides, also it has some negative sides to it, right? There's a lot going on regarding AI, and I think it's quite hard to map this landscape these days if you're not really familiar with it fully, because there's so much going on. So first of all, to make it sort of clear and embed our panel in a real life, I would like to ask you, what role does AI play in your responsibilities, in your job? How does AI kind of, make the difference for you in your kind of daily endeavors, but also in your, practical assignments in your jobs? Let's start with Ulrika, perhaps.
From a telecommunications perspective, which is the company I work for, Ericsson, AI is becoming more and more important, actually. And I've been personally actually pushing that the last 10 years. And the reason for that is that the complexity in the telecommunications area is increasing rapidly. It's because we are entering, a situation where we have many technologies coexisting in the network. So we have 2G, 3G, 4G, and now 5G is coming. And on top of that, we have IoT as well. And with that comes more devices, more connectivity needed. It's also more expectations in terms of what needs to be managed and how we need to respond to users adding, downloading new apps and the performance they are expecting. It's becoming so difficult for the human brain to actually manage that in a real-time setting that we need machine intelligence, as I refer to, rather than AI specifically, because it's about intelligent machines, right? So we need to have the help of algorithms to actually fine-tune and adjust in real time, both in terms of in a base station, for example, but also on the more services side where we operate in the full network and work together with the machine to get a recommendation and then have, so to say, a human take the final decision on what to actually implement or adjust or tune.
Okay, so we had a very interesting, I would say, disambiguation here, where you said that actually you prefer the term machine intelligence rather than artificial intelligence, which is, I think, very interesting. Perhaps we'll come back to that. Jody.
So, how many of you know about Singularity University? Oh, good. There's a couple of you. Okay, great. So for the rest of you, Singularity University is an organization dedicated to solving 12 of the world's global grand challenges. Those include things like hunger, health, education, prosperity, water. So the way that we apply artificial intelligence is to solve these types of problems. So for example, I'm working with a massive credit bureau in South America to understand how artificial intelligence can be used to help solve poverty. We're also working on technologies with all sorts of organizations from the World Bank, the World Food Program, as well as large multinational corporations to use AI in this sort of way. Personally, I work on creating superhumans. What I mean by that is rather than creating supercomputers that we have to be trained to know how to operate, I prefer to create technology that understands the human and adapts, responds, and augments our abilities. And so I use artificial intelligence to deal with things like privacy, but also to deal with things such as understanding human intent and being able to intelligently provide the right superpowers, technological powers at the right time to do whatever it is that we're trying to accomplish. So quite a different set of things.
Well, very, very ambitious and very interesting. Przemysław, well, the name of the company is Ulam AI. And Ulam is such an important surname, I think, for the history of technology. So what is it that you're dealing with?
Yeah, that's right. I can explain where Ulam comes from, but maybe I start with the fact that for me the most important is actually creativity and how AI can enhance human intelligence. So my background is in pure mathematics, and this kind of thinking about machine intelligence and how it can influence and help researchers do their work is very underlying basically everything I'm doing right now. So right now I'm running basically Ulam AI, which is a technological group. There are a couple of startups, and each of it is actually pushing the frontiers of research in AI. We're trying to basically push the research and apply it in very concrete problems, from logistics to fashion industry to quantum computing. And by doing that, help people solving very hard problems.
Well, I think, you know, for all of you who are following what's currently happening with artificial intelligence, what we can see is that there is a certain promise attached to it, that, for instance, deep learning as a particular methodology within machine learning, which is at the core of AI today, can solve certain problems that we cannot solve, for instance, by ourselves, using this computational power here in the brain, right? So we get to see perhaps certain promises and sometimes already fulfillments of how artificial intelligence, machine learning perhaps in particular, can help us, support us, augment us even perhaps, right, in our tasks, those perhaps minor ones and also those major ones. On the other hand, we get to see also certain threats. That's something that has been addressed already in the intro by Renata, that many people feel threatened by artificial intelligence. They feel a bit lost. They feel that perhaps some sort of algorithmic management system will take control over their lives, right? So in order to kind of perhaps have a clearer view on where is it that we stand, you know, and what is real and what is not, I would like to ask you, since 2019 is approaching really quickly, what's ahead? But not really far ahead, but like what to expect now. What do you think are the most important fields where AI can help people, perhaps revolutionize them even, and where it can be applied in the shortest possible perspective, meaning 1 year, 2 years, perhaps? Jody, you want to start?
Yeah, sure. So I think a lot of people are terrified about AI taking their jobs, and it might be true, because there's certain rote tasks that humans are now consumed with in their day-to-day work, right? Things that we can easily pass on now to an AI to do more effectively, more quickly, and at larger scale than a single human being can do. For example, looking through records to find a particular type of person, or looking at scans of cancer and, or possible cancer biopsies and finding the ones that do have cancer. These can be done much more rapidly with an AI that's been well trained. What we don't have right now is AIs that can think, to your point, creatively, right? They can't, like human beings are, even if you're don't consider yourself creative, your brain is inherently very creative. It's what allows you to walk down the street, right? Because you're constantly having to improvise and navigate and change slight things about your step in order to be able to continue. But machines can't quite accomplish that just yet. So that's a bit of a ways away. When I think about AI taking away the jobs that are, like I said, the very repetitive jobs, or the ones that require a specific type of analysis, that we can train those AIs based on existing data, and I think that's a really key point. Train the AIs based on existing data. What it says to me is, this is a huge revolution that means that we can finally start to focus on problems that we've never been able to solve before, because we can pass off a lot of those types of tasks to an AI that frees up humans to be able to do other things. When it comes to healthcare, for example, AIs that can do better diagnosis of, say, pneumonia than even the most trained lab technicians means that the doctors now don't have to spend time reading over charts and trying to determine who has pneumonia or not. Instead, what they can do is focus on the human and the human relationship and the mental health of that patient, which is a totally, many doctors say they wish they had more time for that, and now they will. And so I think that's what we're going to start to see when we see these AIs take over certain pieces of our jobs, is that ability that frees us up to do things that we've always wanted to do but never been able to accomplish due to the amount of time we spend on those rote tasks. And I think that's very interesting. The other thing that we are starting to see, and I'm sure you guys have seen this as well, is that AIs are now starting to be able to feed off of dark data, data that has not been categorized by human hands to begin with. Still, it's learning from examples or rules and starting to understand that. And we're just really on the cusp of that part of deep learning, and it's going to be a very exciting year for that particular trajectory.
For sure, that's, I think, very interesting. In terms of deep learning, I think in the very early applications now we're still used to the fact that this is qualitative, very well curated data, right, that we have to feed the system with so that we get results that we expect. You're saying that in the future perhaps this can change, and the scraped data can come from many different sources, and also sources that we don't even locate, right?
Right, well that's what's happening with the Google's DeepMind, I believe they call it DeepMind X, I'm not sure. But that's the one that is learning how to play Go. And the first iteration of it, they taught it how to play Go. And the second iteration, it taught itself based on playing the first AlphaGo. And now this version of Go, all they've done is given it the rules and allowed it to kind of play itself. And then it's already beat all previous versions so quickly and going into places that they didn't even anticipate it would be going. So I think this is the frontier of what we're seeing in that type of machine learning.
Yeah, we are indeed in a very particular moment where the current champion of Go is AlphaGo 0, and number 2 is AlphaGo, which was the previous version, and only number 3 is a human being. So yes, particular exceptional moment. Przemysław.
Yeah, I can maybe elaborate a little bit on that, but the whole field of reinforcement learning, so as you mentioned, AlphaGo, and also the thing what guys at OpenAI are doing, they basically started with Dota 2 this year, and they're thinking about moving to more harder things, also mathematics. The thing they consider right now is whether it would be a good idea to actually try to use those techniques to start proving theorems, because this is like the next level of creativity. That would be very interesting, but that's like a span of like 5, maybe to 10 years. And from my perspective, even though it's extremely exciting and to think about this research, there's a lot of research that was done already, for example, in computer vision, which is still not applied. So, for example, healthcare is a great business niche, business opportunity, because there's a problem with integration of what's done already in terms of technology, in terms of algorithms, and what is already being applied. So there must be some kind of a collaboration between this technology bubble, all the people who are actually creating R&D, and doctors to actually incorporate all that. So that's for me is fascinating. And the other topic that I like, but that's maybe more up to like 5 years, is autonomous driving. And the whole, so basically we're at the level that computer vision is working so well that actually you already in California you can see Waymo cars, like Uber cars driving around, hopefully not running over people, but they driving around. And it's a matter of time actually, and a matter of regulations, when that will be everywhere. And where actually we can call an Uber and there will be a driverless car coming over.
The other thing that we see in Silicon Valley are not even cars, they're autonomous bots that are delivering things like pizza or cookies or whatever that is, because why do we need a car to do that type of activity, which is really interesting.
And all the robots that actually delivering packages, that's also fascinating, and that's also working already.
Well, definitely, you know, you can see that change also in the warehouses where you have cobots working together with people in physical spaces. Sometimes it's a bit confusing because it turns out that machines are ordering, for instance, like the way they manage space and resources is slightly different. As you know, I mean, when you compare it with humans, so humans get to be surprised, you know, about the outcomes. For instance, in Amazon warehouse in Seattle, there was an interesting case where a robot actually decided to put packages in a completely different order than humans. It was quite brilliant, but just very different and very confusing. So, like, it's an interesting frontier too. Ulrika.
Yes, so I completely agree with what you've been saying here. I was thinking that I think 2019 and 2020 will be a lot about applying AI, because it's been a lot about researching, evolving, exploring. Now it's time to start actually implementing and learning from that. And I think if I look at my own company, we have been starting to do that as well in the last 1.5 years, actually trying to put things in live networks. But what I see still is that we are implementing in islands, because we don't dare to set up something big where we have different parts actually working together. I think it comes back to, again, we need to feel trust. People need to feel trust, and so on. I think that's going to look the same in the society, that we need to make sure that what we implement is controlled by the policies that we set up. You can learn this far, but not further than that, before we come to a point where we can actually have bigger systems working together, AI talking to AI and so on. I think that will be, wait a little bit, but in the next 2 years we'll see a lot like the self-driving cars, of course, but there is so much in IoT. I mean, especially from a telecommunications perspective, it's not just about mobiles connecting and talking, I mean, and people using that. It's about connecting the device to the device and everything that enables, of course, in the healthcare business, but it's everywhere. It's in mining industries, it's in production lines of different sorts, it's everywhere, and I think we will see a lot more of applied AI going forward.
Mm-hmm. Yes, well, I think most of you kind of interestingly formulated your answers, because on one hand you said, you know, what to expect. On the other hand, you actually, in a way, preceded my question that is about main challenges. So many of you kind of highlighted that somehow. We can say that there are many different challenges in terms of AI deployment, perhaps regulations, perhaps dialogue with the larger society, and you mentioned trust, Ulrika, and I think it's a major factor here. Perhaps in some way also more daring attitude on the side of companies, R&D departments and companies, in terms of, well, trying to use this, on one hand, very promising, but sometimes very hard technology for solving real problems. So Recently, there was a very interesting report published by the school where I'm affiliated, which is MIT Sloan. They were trying to show how in 2017 and in 2018, various big companies were using AI. And it turned out that there are pioneers in the field, but actually the mainstream is quite hesitant, right? So that it turns out that on one hand, AI is this big buzzword that we're talking about so much, and it appears on all these panels and conferences. On the other hand, when you dwell deeper and you try to dig, what you see is a bit of a problem in terms of translating that into practice. So I wanted to ask you actually two questions here. Which challenge do you perceive as the most important one right now in 2018, 19, 20? Is it more related to society and accepting AI? Perhaps is it more related to regulations, or like building some sort of, way of translation of what we claim AI could be to like real world problems and applications? Or perhaps is it something else? That's one part of the question. Where do you see the main challenge? And also, do you have any recommendations in terms of how business could implement AI, organizations could implement AI on a more quicker pace? Or is it perhaps not relevant to do it quicker? And I think we could perhaps start with Jody. I'm quite sure that Singularity University has a lot of expertise in that, so happy
yes,
to
this
hear.
is a problem that comes up quite often. And in fact, we meet with so many different organizations that are interested in AI, but they haven't deployed it yet. And there's a number of reasons why. And one is, for example, in one of the healthcare companies I work with, what they experienced is that they tried to deploy an AI robot assistant for delivering drugs in a hospital. And what happened is that the hospital workers cornered it trapped it in a corner with different physical barriers, such as trash cans and things like that, because the workers were concerned it was going to steal their jobs. So there's those types of concerns. The people that are supposed to be benefiting from it are terrified and kind of trying to keep it out. The other problem is that the number of people that are able to actually create AI systems are very few, the skill set. There's not enough skilled workers that can do this type of work. So by the way, if you are wondering what you should get into, I highly recommend getting into this field. It's a very lucrative field, especially right now. But there are ways around that. For example, sponsoring challenges at universities, looking at doing open calls for ideas and innovation. And other types like that. So if you want to know more about that, I'm happy to talk to you. Also, the other thing that we see is that a lot of these organizations, their data, they're willing to deploy it on a specific small data set. But it's so costly that deploying it it doesn't have to be costly, but the way they go about it is so traditional approach to it that deploying it just to one little bit of data is really not going to show them the benefit. So maybe they try it and it doesn't really do much, and so they stop doing it. So I think that's the other challenge that we see.
Okay, and in terms of major challenges, which one would you locate as the most important one? The society, the regulations, perhaps internally in the tech, problems that we haven't solved yet?
I think it's the talent issue. The talent issue is the number one thing that we hear. People are very eager to deploy this in their organization, but they have no idea how to get somebody to help them do it. And so that seems to be the number one reason that these companies are not deploying AI.
Okay, Przemysław?
Yeah, I agree with talent that that's the main challenge, but to elaborate on that, there are probably two things inside beneath that. The first one is lack of talent, and actually the fact that most talented people are going to like Facebook, Google, Amazon causes that whenever you talk with a client outside of, say, Fortune 100, then there's a problem in terms of technology, because they are not willing to admit during the first couple of meetings that they're working basically out of Excel spreadsheets, and they need to start with from the very basic level. And that's the problem with the lack of talent, because they can't find data scientists to put the legwork. So that's again the part where you have to apply the research you have right now to practical problems. And the second thing that's probably I'm thinking about my favorite part about machine learning, and which is a bottleneck right now in developing AI. is reasoning and actually inferring from facts. So this is something counter machine learning, which is very probabilistic in nature, whereas logic is 0 or 1. It's either true or false. And there's a hard transition from this thing, from machine learning to logic, and nobody right now knows how to do it. And this is like a research problem, which is a very crucial one. Also, in order to actually go from like large data sets into small one, I think you mentioned before that this trend of actually trying to do something interesting with smaller data sets, there's something called one-shot learning, which is working sometimes very well with robotics, when you actually show to a robot like which Mac to move and which, that's great. But apart from that, it's very hard to do in general. But it all starts with talent. So there's talent, and there's this machine intelligence, and on the client side, practicality as the challenges.
So if I am not mistaken here, what you're emphasizing here is, on one hand, the expertise, but also on the other hand, certain technical problems that are kind of internal problems about, like, you know, for instance, I work in natural language processing. We have a major problem in transition from natural language processing to natural language understanding, right, per se, and giving certain context awareness to the system that it still doesn't have, right? So it's still a manipulation of sentences, or like certain poor or less poor dialogue management with some speech synthesis, but there is no reasoning, and the context is kind of lacking.
Right, so if you want to go beyond statistics, you need logic, and that's like everywhere. Language is probably the best, because if you want to understand language, then you need logic, but then it also appears in learning from smaller pieces of data. And this is the problem everywhere whenever you try to use machine learning, deep learning, or whatever it is.
Okay, so before I go to Ulrika, Przemysław, because I think it's a very interesting problem here, right? So we're talking about forgetting singularity, but as I said before, it's actually not so easy to forget about singularity, and certain, you know, promises of a more robust, at least, artificial intelligence. I'm not talking even about general artificial intelligence. I'm talking about something that could be actually more of a holistic, right, system that really is an ambient intelligence, if you will, or has that context awareness, can be comparable to humans, at least on some level. And what is the state of the art here, you know, in terms of research? It's a frontier thing, but, you know, 2018, what about 2019 and 20? Do you know of any research projects, perhaps, that could tackle this particular, you know, interesting technological problem?
Yeah, so as I mentioned before, for example, guys at OpenAI are thinking about applying reinforcement learning. So that's like deep reinforcement learning. So whenever you have an agent which is operating in a world and trying to do something and learn from the prizes, that's reinforcement learning. That's kind of an approach to this problem. I don't think it might solve the complete problem. It might give you closer to the solution, but you need like fundamental breakthroughs in thinking about machine learning in order to overcome that difficulty. Because actually this kind of bottleneck, I personally believe that this is the thing that separates us from current machine learning and artificial general intelligence. Like this is because the only thing like basically machines can right now understand most of the text, most of the images as well as we do, but the thing they're missing is actually transfer learning and really take like reasoning upon the facts they already have.
May I add to that? So one of the things that's really astounding is that by the year 2019, we're going to have, I don't remember how many zettabytes of data, but it's astounding the amount of data, because we have sensors everywhere, we have cameras everywhere. The amount of data we're going to have in 2019 is equivalent to 2 stacks of books from here to Pluto. I mean, that's an astounding amount of data. But like you're saying, the problem is that when we do machine learning, it's on a single vertical of that data. For example, you know, if it's learning language, it's only looking at words. If it's learning images, it's only looking at images. And what's different about our brains is that we do both simultaneously. And so we can connect multiple contexts, like you were saying, in order to really understand a greater, the bigger picture and infer the contextual information necessary to make certain types of decisions, and artificial intelligence is not yet capable of doing that. And one of the biggest problems that we see in a lot of organizations is that their data is so siloed in a similar way. One group of the organization has their data in a certain format, this part of the org has it in this format. They don't have a commonality in the way that they communicate across these things, and so creating an AI that can help to connect to those types of contextual dots is not possible to create because the raw data is not in a format that it can do that in. So I think this is a really big challenge.
So big internal challenges plus lack of expertise, lack of enough people in the field, because we all believe in swarm intelligence, so perhaps if there are more in the field, they will solve these or tackle these issues better. Ulrika, how does it look like from your perspective in terms of challenges? Let's come back to that, and perhaps let's try and think also in the context of your organization that is, again, at the technological frontier here.
Yes. So I agree with that we, of course, have technology challenges in terms of reaching the full potential. But I think what we are lacking also, we do have the data, we do have a lot of technology and techniques available to us, and we do have the computational power now. We can do things in the edge, on devices, we can do it up in the cloud and so on. But I would like to see more broad implementation of basic AI in parallel to research advancing the technology and so on. And I think the reason why we might not be seeing that so much is because the way we are implementing AI today is very much from a product, maybe service perspective. We are not advancing that much internally in organizations. And I think that would be a way to also get it demystified for people in general, because it becomes something very technical, very difficult to understand. It's a black box thing happening people don't understand. And I think if we can get more people to understand what's happening and what the benefits are, we could see a broader base starting to happen, and then we can build upon that to get the real interesting stuff happen on top. So from that perspective, I think explainability in AI is very, very important. It's to know what the algorithm is doing, understand why the decision was recommended or taken actually in a situation. I think that is going to be challenging because it's not that easy to technically, especially if we talk about difficult techniques like deep learning or reinforcement learning in combination with deep reinforcement learning and things like that. It's difficult to get a good explanation why did that happen, or why was that decision taken or that recommendation given. I think that's a challenge, because if we can get that more approachable, then people will start trust it, and we will see it happen. They will understand what the benefits are and drive more than ask for, I want this in my organization. I want this to enable my company to be more powerful. And if we can make that happen on a basic level, we will have the other things happening on top.
If I may, this is the problem in healthcare, for example, that you have these black boxes of deep learning, and you actually can't really explain how it works. So how you would actually convince anyone of using that and basing their judgments, medical judgments, on this black box? This is the problem of trust, basically. That's,
I think, a major issue that is definitely worth discussing. So in March this year, I saw at MIT the first kind of presentation of something that is called a net dissection tool that is supposed to work with deep neural networks and kind of uncover their layers and see how the information was processed in order to somehow tackle the issue of black boxes. But the problem that appeared immediately after they announced it, and it seemed like such a great success, was that it only scales to image processing and not to other domains. And there is no really other way to go around it because, well, image processing is quite specific, I would say, and there you can dissect those networks somehow. Whereas in many other domains where actually a deep learning could be so applicable and probably successful, we have this major problem of explainability. So Ulrika on one hand says that, I mean, we need to distribute knowledge, and thus we will have more empowered people who will feel that, this is a benefit because they can also control it and contribute to this field. On the other hand, we have explainability that Przemysław talks about, which is actually not fully related to, you know, to empowering people. It's actually more of an internal problem. So, you know, perhaps to all of you really, but to Jody first, how do you at Singularity University think about the problem of this black box and, you know, and deep learning? What should we do? How to proceed?
Yeah, I think that's still a really open debate for us. I haven't heard a really great argument one way or another. I do know that my colleague Hod Lipson runs an engineering lab at Columbia University in New York, and what they did was they created this robot that was supposed to sort trash from food. And so the people that were training the bot, yeah, they were training it, and then when they went back to try to explain to the people, or you know, to write a white paper to explain how it did the learning, they learned something very uncomfortable, which was that the algorithm had learned to look for the two particular researchers that were training the bot because it was more likely to be challenged with a question if those two were in the image. Mm-hmm. So I guess I don't have an answer except for to say this is really a big problem because we don't necessarily know what the algorithm is picking up on in order to make its decisions.
Okay, so I fully agree. I mean, I think we are in a very specific place. Perhaps the question, to narrow it down a bit to you guys, would be a bit of a controversial one. Do you think we should scale deep learning further before we explain? Because personally, I think perhaps this is a solvable thing. It just requires time. But should we really accelerate deployment of AI before making sure that this is, you know, I mean, before we make sure that we know what exactly these systems do? I'm also talking in the context of perhaps some countries or particular organizations that are really willing to deploy AI, but then they see these concerns, right?
Yeah, I don't think there's a way to stop it, actually. So,
Okay.
I mean, even if we decide that we should stop everything, like, there's no way to, like, you know, like, China will never stop anything. Like, but answering that, no, I think, like, we should both scale deep learning and go deeper and deeper. But on the other hand, there's this whole trend of explainable AI, and that's a good trend. Like, and people are actually really involved in that. There's a whole area of research right now around that, so that's going in a good direction, I believe. But I have, like, no understanding of what's happening there exactly. That's also, like, open domain for my company.
Okay, so you would perhaps hope that, you know, if more people are involved in explainable AI, and the good thing is that we see both companies and science being interested in that, we might reach the solution. Ulrika?
Yeah, so I agree with that it's going to be difficult to stop it, but I think it's up to every company to think through, you know, what's the responsible approach for our company? What can we do without losing, you know, control over our products, services, or the offerings we have, and so on. So from an Ericsson perspective, for example, we are thinking a lot about the combination of, you know, experienced people working with the machines and making sure that at the end of the day there is a validation of the decisions. So we're not going to fully automate it, especially on the higher levels where it's more complex analysis happening maybe in different segments, and combining that to a network decision, network-wide decision. If we talk about edge, for example, we have, you know, less complicated. We don't implement deep learning there. We implement ordinary machine learning algorithms that can execute, you know, directly on the policies we have predefined. But if we talk about the more upper layers with more complexity, then we still have human supervision in the decisions. And we hope to, over time, see, okay, this is a reasonable decision, so maybe when this pops up, it can always be approved. And then we can have more and more of these decisions being fully automated, but we still want to be in control, so we don't just let the machine decide.
So you want to, in particular domains, you want to rely fully on human expertise, and you want to kind of, even when there is an option of using deep learning, perhaps more supervised techniques as they are safer would still be chosen as better ones?
We are starting in that end, and then we are exploring more and keeping that under more strict control when it comes to the deep learning part. But yes, I think that's where we are at in terms of implementing, because it's also quite severe when we now start thinking about machine-operated telecom networks. If something goes down, boom, it's the entire network. You know, it's quite severe if it's on the network level. So we want to make sure we can stay in control over this. But I see definitely over time this will evolve, absolutely. But we're just being careful that we don't, let go of too much power from a human perspective. But it's definitely at the moment where we are empowering ourselves a lot from an intelligence perspective with having the algorithms look at various data sources, analyzing that in real time, really looking for patterns or deviations so we can prevent and proactively detect problems before they happen, and then make sure we can remotely make sure that we adjust the network to fix that. So from a user perspective, the experience will be that the network has no problems because we have prevented that. Instead of like it was before, something happened, an alarm was triggered, and then we had to go and fix that, and the network was maybe down or unstable for a bit. That will, we'll see less and less of that because the machine will tell us, oops, this pattern indicates that this will happen now, fix it. So, I mean, it's a lot of these things, and that's just a start, as I see it. We can do so much more with all this data that we have.
I also have another question to follow up on that, and obviously all of you can contribute, but perhaps I would keep Ulrika here for now. This digital transition, I think for bigger companies, bigger organizations is, as said before, a big promise, but also a big challenge. How do you strategically kind of prepare for that? What are the most important things that you are currently doing to make best benefit of it?
So it's a very good question because we are right now focusing a lot on that. I mean, Ericsson is a very big multinational company. I mean, we are in more than 180 countries around the globe and around 100,000 employees. So, and we're also old. We're more than 140 years old. So we have a lot to struggle with. We're big, we're slow. It's difficult to change. But what we have discovered is that it's very difficult to get the real change to happen if we only become data-driven in one area or one segment or starting implementing that in islands. So what we are trying to do now is really to fundamentally change everything in the business, from how we sell, how we operate, and both internally but also what that means from our portfolio perspective. So it's a big challenge, and it's challenging a lot at the core of the company, I think.
Jody, Singularity University is also working with many companies, I think, really advising on such transitions. Can you say if, perhaps a few recommendations to bigger organisms, how to make benefit of that?
Yeah, I think the first recommendation that we have is really around creating parity or common language of your data and being able to create APIs to the data so that different parts of the organization can tap into a data from another silo, et cetera. And that seems to be the most important first step in creating the ability to really use this digital information in a powerful way for your organization.
Przemysław?
Yeah, I'm working mostly with companies who are already digital in certain sense. So there's no, because especially in quantum computing, we also do that. We actually need people who already understand machine learning in order to go further. So there's no point in talking with a company who actually hasn't been in any way digitalized.
Okay, well, this seems, to be a very interesting moment, both for big companies and for small that are more agile, perhaps, and thus it's a bit easier to adjust. Many people who are interested in the field know that AI has been through its summers and winters already. And, the discussion about singularity, we were supposed to forget it, but obviously we won't, has been going on for such a long time. Because from the birth of artificial intelligence, we had the discussion, how far can it go? What can we reach with that? Can we go beyond certain thresholds that we think are very hard to kind of reach? And my question is, in terms of this whole weird sinusoidal kind of, I would say timeline where you have summers, winters. Where are we now, and where are we going to be soon? Do you think that we are in the deepest summer of artificial intelligence, or not yet there? Perhaps it's more of a spring, and what follows?
I'd say it's early spring. Early spring. It's just starting to thaw. You know, the thing about it is that, you know, the AI is on an exponential curve, bringing out some of my singularity. And, you know, all of it is being driven in large part by the computing power that we have available. The machine learning that we're using now, deep learning, was actually thought up in 1956. It's just that we didn't have enough data and we didn't have enough computing power to do it. And so logic-based AI was really the driver of that. And what you see when you look at one of these exponential curves, and especially Moore's law, what you see is that it's actually made up of a number of S-curves, of different paradigms of technologies that are picking up where the other one levels off and accelerates it even faster to the next S-curve. And so right now we're in this deep learning S-curve, and it's going to eventually reach a point where it's pretty much leveled off. But already we're starting with Alpha 0 and these other things to see that next paradigm kicking out. You know, I would say that there's probably 6 or 7 different paradigms. We've already gone through maybe the first 2. The next one really is around creative machines, and we're starting to get into that S-curve now.
Yeah, to add on that, I don't think machine learning is going away anymore. The winters before were basically caused by the fact that, for example, in the 50s or 60s, that you have these big expectations, and basically if you look at the papers, researchers in the grant proposals were saying that, okay, we're going to build intelligence which is similar to human intelligence already in the 50s and 60s, and that was way too early. And after a couple of years of not getting those results, basically all the funding was gone, all the investors were gone. And then it happened again, I guess, in the 90s. And it was also too early because of the computing power. And right now, finally, I guess in 2006, 2007, we got to the point that actually we have so much computing power that we can process all the data we have, or like most of it, and get something practical. And once you have something practical and you have like real money involved in it, it's not going away anymore. It's only going to get deeper and deeper.
Ulrika, spring, summer, winter approaching, winter coming.
I think it's still early spring, like you say as well. But I think it depends a little bit on which brand, sorry, which business you're in and business area, maybe. But from a telecommunications perspective, it's definitely a point where more and more people in management definitely see the potential of this for the companies. So that's why we have seen a big move just the last 2 years now, and it's moving faster ahead. But like I mentioned earlier, I still think we're at the point where we have capabilities being on different places, in the edge, on the central level, in the middle layers as well, but it's not working together yet. And I'm looking forward to that. I'm looking forward to when we can have an AI pushing the most suitable analysis to the edge and doing the most suitable analysis on the central level and having it like an orchestra playing together. That's what I'm looking forward to.
I think there is one more question, and obviously, you know, also open to your contributions, and that's sustainability, right? So in terms of computational power, for instance, when you look at blockchain, which is such a fantastic protocol of the future, you see how much energy it eats up, right? And how, let's say, environmentally unsustainable it still is, right? So the same can apply for, you know, the computational power that we need in order to, well, create more cognitive machines, or like, I don't know, more intelligent machines. So I don't know if this is something that would be interesting for you to discuss, but I think this is another issue. Yeah, Ulrika.
Yeah, just a comment on that. I mean, we also see another trend is that we are seeing the telecommunication networks virtualizing. They're being virtualized and put into the cloud, the networks themselves with the products and all of that. That makes it even easier for us to use the data and implement different types of AI on that. And one of the things we have been experimenting with is energy efficiency. Because when you put it into the cloud, we see, oh, it's consuming a lot more than we thought. So we have actually started on a deep reinforcement learning model, which has cut down the energy efficiency with 25%, or increased the energy efficiency with 25%, which is significant if you look at throughout the whole network, what it means in cost, but also in energy savings. So I think we'll see a lot more like that as well when we virtualize more and more of our different environments.
I see you.
We are being stopped.
Okay, we need to wrap up. This is such a fantastic discussion. I guess we could discuss like that for a few more hours, so many open questions. Thank you, though. Thank you to Jody, Przemysław, and Ulrika. Big round of applause for our panelists. And thank you all for attention. Have a great day and with fantastic, fruitful debates on technology. Thank you.
Thank you.
Thank you.
Thank you.
Thank you so much. Thank you so much. As Przemek has said, it is so hard to stop people discussing deeper and deeper artificial intelligence. Quick announcement. So as you could see, we're slightly over time, but I think it was worth listening a little bit more. Humans discussing artificial intelligence before the roles swap, and we will be hearing in the future artificial intelligence discussing human intelligence. So we have a couple of minutes for a quick break. If you want to pop up, get some coffee and come back. We will start in about 5 minutes with the next panel discussion in here, or if you want, there's workshops, seminars, etc. outside. If you wanted to sign up for a mentoring session, there is a mentoring booth just outside in the main hall. In the meantime, please enjoy your coffee. And this is a long